So we're going to talk about passwords, and any discussion about passwords is fundamentally a discussion about personal security. And there are three pillars of security, and you who have worked in the federal government and security clearances got this drilled into you. When you are trying to manage your security, it's what you know, that's the secrets or the information that only the authorized user would know. For example, your password or a PIN or answers to security questions. I'm sure all of you have experienced this recently. If you're like me, I'm always going to a doctor. What's the first thing they ask me? What's your full name and birthday? That's information that I know, and that tells them that I am who their appointment book says I am. It could also be what you have. For example, physical or digital tokens or devices that you possess. For example, your smartphone that can get a text message and the one-time code that they send to you. There used to be the hardware keys that you had. These are things that you possess. Or it could be an ID badge that allows you to get into a computer by tapping somewhere. Or it could be what you are. And this deals with your biometric traits. Anything that's uniquely physical to you, your fingerprint, your facial recognition, or retina scans. So there are a whole number of terms that are used, passwords, passcodes, or passphrases, that all deal with these three pillars of security. And these are going to be important as we go through this discussion. So passwords, of course, aren't anything new. We had the Arabian Nights and trying to figure out what Alibaba was going to do and how he's going to get into that cave. He had a password. Dan Brown had the codex and was able to get information about Newton by fiddling with the codex and coming up with Apple was the clue, password to what information that he needed. And if some of you aren't old enough, probably, that's about the Groucho Marx and the trying to get into the speakeasy with that whole thing. It's a hilarious skit. But so these aren't just computer things, but passwords have been around for an awfully long time. So the purpose of the password, like a license or a badge, is to verify your identity. In computer terms, it tells the websites that you are who you say you are. You have a responsibility to validate your identity. So you need to know your password, and you need to protect your password so that somebody else can't say that they are you and therefore get into these services. So today we're going to talk about how to manage that responsibility. Let's take a look at a common password architecture. You get Homer Simpson. Comes up to his computer and he wants to do some work on the internet. And he has the choice of going to Home Depot, Amazon, or Bank of America, or whatever. Of course, he's going to choose Homer Simpson Depot. And he's going to say, hey, let me in. Well, Home Depot's server is going to respond, well, who you are. So they send them a form and say, what is your username and password? Homer, of course, knows his username is Homer. His password, of course, is my password. And we send into the form and sends it off to their server again. And then they check their records, things that he had set up when he created his account. Goes back to their database, and sure enough, everything's working fine. And he gets into the Home Depot server. So that's basically the architecture of how you're putting in passwords works. But the difficulty with passwords is we have certain capabilities that are limited. As the architecture diagram indicates, the best place for people to steal your online identity is either from you. They can trick you into giving away your password. Phishing is what it's called. Or from the websites you visit, where they would hack into the web servers at any particular company and gather up all the passwords that are there. To be useful, passwords have to be easy to remember. Most of us, our information technologists tell us, can easily remember 7 plus or minus 2, so that's 5 to 9 unique characters or symbols, unless they are chunked by a recognizable pattern. For example, common patterns like a user significant dictionary word, or numeric sequences, or a combination of those. People prefer convenience to security, right? So that's what we call security friction. A large majority of database breaches, or data breaches, about 81% in fact, are linked to weak or stolen passwords according to the various security reports. So password complexity is an important item. Most users are lazy when it comes to password creation. In 2019, the United Kingdom's National Cybersecurity Center analyzed public databases of breached accounts to see which words, phrases, and strings people used. The most popular password on the list was 123456. And it appeared in more than 23 million passwords. The second most popular string added 789 and was not much harder to crack. While the top 5 included QWERTY, easily input from the keyboard, the word password, and the string of ones. And we haven't improved since 2019. The most common passwords in 2025, NordPass determined, were pretty much the same things. The number 1 was still 123456. The second one was added 789, and password and QWERTY also showed up there. Now I talked about the string of ones. Well, the difference is that the string of ones with the 7, the number rank 7, and one number 18 are either 1 over or 1 under what was in the original. So it's a wash. It's still 111s were very popular. So the National Institute of Science and Technology has been making recommendations about passwords and how to secure all the various sites. And in April 2025, they said that the most important characteristic of a good password is length. So this recommends passwords be at least 15 characters long. A little bit higher than the 7 plus or minus 2 that we're good at remembering, right? This no longer recommends the requirement that passwords have numbers and special characters, though some websites still require them. In addition to the password issue, they recommended to use multi-factor authentication, which really is 2 types of passwords, 2 pillars of security combined. Passkeys are one of the newest, greatest options. They also suggested that because of the human difficulty in remembering a 15-character string, that you use a password manager. Let the computer do the work for you. And of course, just common sense. If your password manager tells you that your password has been exposed in a data breach, you should change it real quick. So we're going to talk about how to implement the NIST things and the long password recommendations. The first one that they talked about. You can create a long password of greater than 15 characters by using a passphrase. It's a string of unrelated words like billboard, cloud, battery, which is 21 characters. And it's very difficult to guess that password because of the changes in what those words refer to. But the easier thing is to allow the password manager to generate the password. The second item they talked about was multi-factor authentication. You can implement multi-factor authentication by choosing that when you are at a website, for example. And it enhances the security by combining at least 2 of the 3 pillars of security. So the ubiquitous 2-factor authentication combines your password, log in, it's something you know, with a code. It's something you have because they're going to send that code to you via an email or a text message or a phone call that you're going to input back in, and then they will let you in. Other 2-factor authentication methods include biometrics, magic links in an email. I'm sure some of you have gotten those where they say, we'll send you an email and then you click on that link and we'll verify that you are who you say you are. The use of social media accounts. Sometimes you are asked, well, would you like to use your Google account or your Microsoft account to validate who you are? Or there might be a security question, like, what was the name of your first puppy? So everybody has puppies. So let's take a look at, since this is a little deep into the technology behind those texted codes that they sent to you. The time-based one-time password. It's a secure 2-factor authentication method. It uses a secret key in the current time to generate the unique 6-digit code that changes every 30 seconds. You only get so long before that thing expires. Because the code expires quickly and is verified offline, it's highly resistant to phishing because you don't necessarily know that ahead of time to be able to tell anybody what it is. And it's difficult for interception because it happens so quickly. The process basically involves 3 ingredients. You have a shared secret. It's a unique string of characters, or it could be a QR code that you scan when you first set up your 2-factor authentication. It's safely stored on both the website server and, for example, your phone. Then there's the time factor. In the current universal time, which is unit time, and it divides it into specific intervals, usually about 30 seconds. And then there's an algorithm that all of this is run through that creates a mathematical formula and it combines those 2 items. So the generational step, then that last part is to calculate the timestamp. Well, everybody knows that a computer has the ability to get the time. And it can calculate the 30-second blocks that have passed since January 1st, 1970. And this number changes every 30 seconds. The next step is mix and hash. So they run that 30-second block and the shared secret through a cryptographic algorithm. And it generates a long string of random letters and numbers. It's a 20-byte hash. And then it goes through a truncation process. The algorithm mathematically extracts a tiny 4-byte piece of the 20-byte hash and converts it to a standard integer. And divides it by a million to get the remainder. A million because there are 6 zeros in a million, and that's what's going to call the modulo that comes out of that. And then the display is the result of 6-digit code. The servers allow for a few windows before or after the account to allow for clock delays. But pretty much, everybody's going to agree on the receiver side and the submission side what those codes are and whether they're valid or not. So that's how you get those little 6-digit codes that everybody has. There are a couple of things that I want to stress here, first of all, is that there are, in addition to all the passwords and usernames and everything that you have to deal with on the web, there are a few essential computer passwords. Biometrics and fingerprints and facial recognition and all that can substitute for these passwords on many of our devices, but it's important to have these to know them. The password to your device is very important to know. If you can't get into your computer device, you have no need for the computer passwords. The password of your internet network, you need passwords for the network in your home to access external internet accessible services and applications. It's usually printed on your router, so unless you've changed it, that's a good place to go look for it. And the other one is the password to your cloud service. Your Apple ID, your Microsoft account information, or whatever that might be, because you're going to be asked for that sometimes to go through the authenticator on your computer to say who you are and validate it. It gives you access to important services provided by your operating system's cloud. For example, Microsoft Store or Apple's App Store as well. So these you really should know at a minimum. So the third part of the NIST recommendation is to use a password manager. Well, we're going to talk about three different types of password managers. There's the do-it-yourself variety. There's the one that's built into your browser. You know, you could log into Chrome or Safari or Microsoft Edge. This is where you're going to have a browser-based password manager. And then there are the standalone applications that are not necessarily browser-based, but they do operate with browsers to do the autofill of passwords and so on. So the do-it-yourself password managers, I'm sure you've all dealt with this. You know, you've got your, a whole array of beautiful Post-it notes with all usernames and passwords for everything you get into on your office wall. Or those of you who are much more sophisticated, buy a composition book. You write them very neatly in there. And of course, everything is always hunky-dory in there, unless you misplace that in a book. So the do-it-yourself password managers do have a few problems. Recording, retrieving, and updating the password is time-consuming, and it's error-prone. You know, if I transpose a letter or a figure or whatever, then I don't have that password. It requires transcription from paper to the computer, which also can be error-prone. It's nearly useless for mobile solutions because unless you have your computer and that book together, you can't do anything with the passwords. Backups, of course, are problematic, and sharing is, of course, insecure and difficult. Browser-based passwords, these are password managers that are built into the browser that you use. Chrome has one, Safari has one, and Microsoft Edge has one, as do most of the other major browsers. Safari uses the iCloud keychain, which is a built-in part of the iOS operating system. It can be accessed through the settings icon on your phone, for example, and through the password or the password app. Google Chrome stores passwords in your Google account. It can be accessed from Chrome by clicking the three-dot menu and then selecting password managers. And we're going to see that in a moment. Microsoft Edge stores passwords in your account on the Microsoft Cloud, or it can be encrypted on disk if you're offline. It can be accessed from Edge by clicking on the three-dot menu, just as you do for the Google Chrome, and selecting passwords. So this is what Safari's looks like on the iPhone. If you go into the gear icon, which is settings, you'll see, and you scroll down, you get to the apps part. And scrolling down through the apps, you'll see passwords. Once you click on passwords, you'll see the middle screen, and you can choose the type of passwords you're looking for. And once you do that, it will open up a third screen so that you can see what URLs or applications you're working on. And by clicking on the arrow, you'll be able to see your username and your passwords, but they will initially be visible, but you can make them visible on that next screen. You can also use that last screen by using the plus button there to add your own passwords manually, as opposed to having them saved automatically when you're on a particular website. If you look at the top of that last screen, it says turn on the iCloud keychain. That is so that you get the passwords that you put onto this device, excuse me, to sync so that your other devices that are on the cloud, the Apple Cloud, iCloud, get to see those passwords and have that functionality available to you on that particular device. Chrome's password manager is accessible through the three dots at the top of the Chrome browser window. And then you'll scroll down to passwords and autofill. And when you do that, you'll go to Google Password Manager. And then this screen will come up. As you've seen, I have ERP, of course, as one of my websites. And if I go over to the item to see what's there, it may ask me for my password to my device, because they're not just going to let anybody come in there. So that's why, as I told you before, those essential items, like how to get into your computer, are important to remember. On an iPhone, it looks a little bit different. In the Chrome Browsers app, you click the three-dot menu, it's usually at the bottom of the screen, until you see the password manager icon. It's this little guy over here, password manager, and then it opens up similarly to what I showed you before for the desktop variety. Microsoft Edge works similarly. There's a three dots on the browser for Microsoft Edge. When you click on that, you'll see the first little screen over there where it says passwords. Click on that, and then the password and autofill password manager information comes up. They all work pretty much the same way, but it's important to know that these also can generate passwords for you. So just to give you an idea of how this works normally, and this is very much simplified. When you visit a new website and create a login with your username and password, your browser will automatically ask you if you want to save the login details. So say yes, it puts them into that password manager. The next time you visit the website, your browser will autofill that login, because it knows that there is a form, a web form, that is asking for a username and password, and it'll just fill that information in and keep going. There are advantages of this, obviously, is that it's convenient and it's pretty user-friendly. The passwords are encrypted on your device. Some have a useful password generator feature. Not all browsers do that, but most of them do nowadays. Passwords are synchronized across all of your devices using the same account. So if you have a Google account, it will be synced across all of the items that use the Google account. Similarly with the iCloud or Microsoft account. No payment is required. It's completely free, which is a good thing because it's already built in. The disadvantages are that there's no cross-browser syncing of passwords generally. So if you are saving passwords in Chrome, and all of a sudden you want to use Edge, you probably won't find that password in Edge's password manager. Some of them, most of them actually, allow you to import data from another browser. So your browser can export the data, and it's exported in a CSV file, a comma-separated values file. This is open text. It's not encrypted. Thus the security alert. Then you can import that. If you do this, make sure that you delete that CSV file once you've imported the data, and that you have emptied your trash can, like a computer, so that that isn't available for people to just come in and look at as if they can get it in your computer. They may have limited security features and functionality because all the browsers are competing at this point. They probably encrypt the passwords, but do they determine password strength, which you might have on some browsers and not on others? Do they detect reused passwords or check if your data has been leaked on the dark web? Those kinds of things are somewhat important. And you want to choose the browsers based upon how well they handle all of these aspects. So the third type is the standalone password manager. These are applications, and their primary purpose is to keep all of your passwords safely stored in one place. There are two types. There's the desktop-based password manager that store passwords on a local device, so you can access them anytime when you're without Wi-Fi connectivity. And because it doesn't utilize a server, hackers can access. It offered very high level security. Cloud-based password managers use cloud storage. And they have automatic backups on the cloud to third-party servers when your data changes. So you can use it across multiple devices and operating systems, which is the big advantage here for these standalones. That if I use my 1Password, which is a standalone, right, I can go to any kind of computer that has 1Password on it and get my passwords for all of the various websites that I visit. Not only that, some of these allow you to store all sorts of information and securely. For example, I have my passport information stored there so that I can access it if I'm in France or whatever. The advantages are that they are multi-purpose use. It stores the passwords in a password generator, resulting in improvement in the security level of the online accounts. So you don't have to try to figure out what 15-character item you're going to try to generate. It can generate that for you. It has great security features. Besides encryption, standalone types rely on the master password only. So there's one password to remember, password to that password manager. And oftentimes, you can use multi-factor authentication with it as well. It's high functionality. Beyond password storage, a typical standalone password manager features dark web monitoring, regular strength test of your passwords, indicating whether you have duplicates or whether they're easily guessed passwords, and there's breach notification as well. So if they found that your password is somewhere been discovered, it'll let you know. And they also have lots of helpful add-ons. Some companies even offer a built-in VPN service. It's a virtual private network for users' online browsing security. So nobody knows where you're really searching from. There are some disadvantages. Payment is required. There are free versions that may be offered, but these may not be as reliable as a paid option. Some options aren't as convenient as browser-based password managers, although I haven't really encountered that in any of the major ones. There's a risk of a single point of failure in that if a user gets into your password manager, then all of your passwords are exposed. However, the strong master password, unique and only you, and enabling multi-factor authentication really mitigates that risk. The one reason that I have 1Password, which is a standalone password manager, is because my son got it for us, because if something happens to my wife and me, they need to get into some of our accounts. And that allows him to do that. Whereas I would have to tell him what my standalone passwords are to get into my computer and all that other kind of stuff. And he would have to use my device in order to get things straightened out in the campus. So that's one of the big advantages. And there's a price break if you have a family grouping as well. These are some of the available standalone managers: Keeper, 1Password, as I mentioned. Bitwarden, the one on the left, the last one listed, is a freebie. It's an open source one. It does have some functionality that you can purchase, but they're all very good. Walking through the pricing is a little cumbersome, because some of them offer for 5 people on the family plan versus 6 people. The pricing has changed a lot over the years. Just to give you an example, your 1Password, you can go on any operating system, basically, and there are plugins for all the major browsers. Family sharing for 5 individuals on unlimited devices is $60 a year, and a single user is $36 a year. They are offering reduction in prices for the first year, as most of these services do. They have a unique feature, it's called Travel Mode, that lets you delete sensitive data from your device before you travel, and then restore it with a click after you cross the border back into the States. This prevents anyone, even law enforcement at international borders, from accessing your complete password vault. It can also act as an authentication app like Google Authenticator for multi-function security. Bitwarden is a secure open source and free with no limits, like I said. It offers a paid upgrade. That's Bitwarden Premium, which is $10 per year for individuals and $40 per year for a family of 6. It gets you 1 gigabyte of encrypted file storage, 2-factor authentication with devices like YubiKey, FIDO, you have Duo, and a password hygiene and vault report. And it also gets you priority customer service. There are versions for Android, iOS, Windows, Mac OS, and Linux. All the extensions, as you would expect for all the different web browsers. WordPass is another one. You can see the various costs there. The premium version includes device syncing, costs $36 in the first 24 months, and then $72 per year for an individual. For a 6 users, a family plan costs $67 for the first 24 months, then $144 per year, and all those prices are subject to change, maybe even today. So you want to check those out first. All data is encrypted on your device, as you would expect, before it's uploaded to the company servers. And it has an emergency access feature, which allows you to grant another DoorPass user emergency access to your vault in the event that you can't get in. That makes it kind of nice. A family plan would allow that anyway, right? So we talked about passwords, but there is, and I'm sure you noticed this, there's a movement to kill passwords. It's moving away, the industry is moving away from passwords for all the reasons that we talked about, all their deficiencies and disadvantages. So what's the replacement? Well, taking advantage of the Internet of Things devices, advanced biometric authentication, and blockchain technologies, user identity verification can be achieved with passwordless login. And I think you have experienced some of this actually. WebAuthn is a new way of logging into websites that may finally free you from remembering passwords. Instead, you'll use your fingerprint, your face, or a hardware token. The WebAuthn API is now an official standard. It was ratified by the World Wide Web Consortium. It's already built into many popular browsers and the operating systems. So now it's up to the web itself to incorporate it. WebAuthn is like a trusted friend that who can vouch for your identity. So how does WebAuthn work? Well, WebAuthn talks to your device's trusted authenticator. Your phone's fingerprint reader, the one that you have on your iPhone, for example. Windows Hello or Apple's Face ID. These are trusted authenticators. If you log into your website that supports WebAuthn, the site challenges your browser to ask your device to prove who you are. In this case, the browser asks your trusted authenticator to supply that proof. Because the authenticator itself is trusted, you don't have to store fingerprint data or anything unique to you on the website. The authenticator is an intermediary, a good friend who can vouch for you. But there's a bit more to WebAuthn, including the encryption of your data with a public key and a challenge sign with your private key that unlocks it. The idea, though, is that you're communicating your secret, your fingerprint, face, or your token, only within the secure confines of your own computer device, as opposed to sending all of that back to a web server somewhere. There are some hurdles for developers, but most of that deals with the legacy issues of how we've always done it. And as long as the developers start to come on board with implementing WebAuthn, all of these things will be pretty much mitigated. Apple's passkey, and I emphasize this only for Cal's benefit, it's the next generation account security. Actually, it was the whole consortium that came together and worked with the Apple passkey, which was obviously first presented by Apple, and they all came on board. Apple's giving it away freely to everybody. It's based on the FIDO Alliance and W3C standards. Passkeys replace passwords with cryptographic key pairs, and these key pairs profoundly improve security. They're strong credentials. Every passkey is strong. They're never guessable, reused, or weak. They're safe from server leaks because servers only keep public keys. Servers are less valuable targets for hackers. They're safe from phishing because passkeys are intrinsically linked with the app or the website that they're created for. So you can never be tricked into using the passkey to sign into a fraudulent app or a website. In iCloud Keychain, passkeys are end-to-end encrypted, so even Apple can't read them. So passkey ensures a strong private relationship between the person and your app or website. And I've included a link in this to, if you want to see a video on how passkeys work, which might be instructive. So, Cal asked that that you abide by what I've said. Yeah. The only thing that I would suggest is stop using the notes that you have to decorate your walls with, and use what's built into what you're using anyway to access the website. You're using your browser, so you might as well use the functionality that comes with your browser to save yourself. A lot of calls that I get are from people who are concerned that they've been hacked. Well, a lot of the hacking is really just phishing. And if you just ignore it, it'll go away. Hacking is when they actually get into your accounts and start impersonating you, because now you have given away somehow, either because there was a leak at the website, or they tricked you into giving away your password, that you no longer have control. So, if you want any help on doing that, give us a call. Are there any questions? Yes, ma'am.
Okay, so I had this issue lately. I decided I was going to get rid of an old email because I wasn't using it anymore. And so I got a new email, new password. But the computer is automatically entering the information of the old password when I was trying to sign into Apple. And things really got confused. So how can I get rid of old email passwords? Old passwords that are like in Google.
That are in Google?
Yeah.
Then you have to deal with Google. It's not an Apple issue. Okay? So if you're going
No,
to...
Google is saving the password.
Right. But...
Yeah, so if they're on Google, that means they're either on your phone or they're on your computer or they're on both.
I know, but they ask you to sign in your
Right.
user ID, but then the computer would automatically put in.
Stores them all, and individually or collectively, you can delete any or all of your passwords that are in the password manager. It's an app or it's a website. You can go either way, but you can delete them individually. You can just click on the ones you don't want, or if they're wrong, you can update them. That's it. It works the same way whether you're in Edge or Chrome or Safari. They can be individually or collectively deleted. They can be purged entirely. I wouldn't suggest doing something like that.
Well, I think she's asking how do I get into that. You go in
Yeah, so in Chrome, you can either go in through the hamburger, which is the 3 dots on the upper right-hand corner, and click on passwords. It's under security. Or it has an individual app. So if you click on the upper right-hand corner and you select the 9 little dots in the corner, those are all the Google apps. One of those apps is the password manager. So you can always go in that way. Edge does the same thing, but it's through the gear. It's a little more complex, but it works the same way.
Thank you.
Yes.
My health insurance has said that I have to set up a passkey. Will that affect anything else, any other passwords that I have?
A passkey has nothing to do with anything other than that particular application. Because there's a public key and a private key that's involved in it, and they are unique to that particular application. Passkeys are nice because it just works. Yes.
So say I want one password. So say I want to purchase it so I get some additional things. So I have to think of a great password first, right? Like 15, 20 characters that I know.
Okay.
And then do I have to enter every single password I have now for all the sites that I go to?
You can import them. Okay. you know, like I said, you can export the CSV file and then import them into 1Password. 1Password also has some ability to read directly from Google's Chrome.
Just remember Jim's comment though, that it's a CSV file, make sure you delete it if you're gonna import and export, import.
A hard delete.
Delete and shred.
Like,
Yeah.
shred it.
Sir?
I'm aware that some financial services are using voice recognition as well as your password. As a way of affirming that you are who you
They
claim.
use CAPT.
Charles Schwab tried that, and I think they've given up on it a little bit, and they have moved on to passcodes. There is a, you can Google it, find out what industries or applications are using passcodes. And I'd probably say Costco is. Yes, sir.
One of the thoughts going through my mind with AI coming on, with the width, the breadth of data they can access instantaneously, and the speed that they can act, is that will a passkey still safe, keep you safe? Because it sounds like they can almost overcome the password managers in the future.
I think for the types of stuff that most users are doing on an application through the web, you're perfectly safe with the passkeys. If you were a work planner and doing top secret planning to take Maduro out, you might want to be on a separate network and have a whole lot more security. Ask NSA to help you.
One of the things, just to add to that, the passwords, the emphasis on Jim's presentation, two-factor is really the thing you want to focus on, and mostly it's things like banking. So don't just use a password manager, or don't just use a stored password for the banking. Make sure that you, when it says you want to implement 2FA, yes, do it. Those are the kind of things you'd be most concerned about, is people getting into your banking information and draining your bank accounts. You can have it. So definitely do password, passkey, and two-factor authentication. It's real easy, it's flawless, because the only thing it's looking for is your phone. You can't, somebody steals your phone, in which case you're gonna lock your phone anyway. That's it. Two-factor authentication is a lot more robust than people give it credit for.
It may be a little more subtle in setting up two-factor authentication. They may say, do you want to implement Touch ID on your phone? That is the same thing. They're saying, you know, we're going to use your fingerprint as that second pillar of security, and it makes it much more secure.
If you have, say with banking, and you want to set up the 2FA, and usually it sends you something to your phone or whatever, can it be more than one number that you send it to? Can it be set up for additional numbers? So if you have a joint account set, and if the other person, you know, you're not gonna have your phone, you're gonna have their phone. So can it be set up separately or together, you know?
When you log into your bank, you're
Right.
logging in as an individual,
Right.
right? It will send the information to whatever device or number or email address that you have put in that profile. They usually don't allow for dual implementations of the profile information.
You see it, password, will say, what phone number do you want to send it to?
Yes.
And you can have two, and you already want to send it via email.
Right, they do make options available,
Okay.
but, yeah, it's,
some people allow you to set up separate logins for joint accounts.
Right.
So my wife and I have a joint account, each one of us have our own login.
Right.
So we have our own MFA.
Right, that's typical. Having a joint account with the same, it's not normal.
So you each have your own password.
Yeah, you really should.
And you each have your own profile, it's called.
One of the things that I see very often doing the business in the community is shared email accounts. You should get away from that. Just don't do it. You should have your own email address, your own security. That's just the right way to do it.
My wife does 99% of all the paperwork for my house, banking, and all this. We each have our own computer, our own phones. She has her own passwords, she's okay, this and that. I just finished up, my computer says, I'm permanent in Microsoft. And it asks for, I try to get into Ancestry. Just finished up my SAR. Well, I can't get into Ancestry because it's asking for a whatever code, and you say yes, it goes to her phone. The same thing with my Centera information. I still can't get in. Not because something happened to her. I had to go to her computer for it to recognize that it's her. And she has a whole printout that she keeps all her passwords on. It's on paper. She says, okay, here's this website, that website, you were saying, one of the investment things, Schwab, and different things. Yeah. So she's got all that, and of course, the auditors, even she's got the passwords for my stuff for the VA and things like that that she can go to. And it's kind of screwing me up right now. How do I change that? Well, one other thing, she's been getting my text, emails, and stuff. Some of that stuff's going to her. I can't figure out why, even though I'm getting it, she's getting it. Unless she's got on her accounts listings on her phone, if something comes in for me, also, I'm added on to her accounts. I have.
So a lot of banking systems will allow you to register multiple emails and multiple text messaging. Things like that, that's fairly common, but to get everything that she receives to your phone and her phone, that's not normal. So you want to look at
I
that.
don't know, so we switched from one carrier to another, that. But, she got a text today from the VA, I have VA appointment tomorrow. And she said, okay, I confirmed that, I said, well, I confirmed it too, the other day, but now there's also a thing, I gotta go pre-register for my visit tomorrow.
It's generally not a good idea to share accounts.
Yeah. I know when I go in to my email on my computer, even on my phone, it's going to come up with my normal email. At Gmail. Well, I have a second Gmail account for my art stuff, on the art committee. So I have to go in and say, I want to go this one or that one. And she's not getting into the art stuff.
Just
That's a separate account.
separate account. The other thing is, with Gmail, they give you 12 accounts, but technically with what you're doing with the ARC, you could just have, John Jones at gmail.com is your normal Gmail, and you can do 1,000 John Jones plus ARC at gmail.com. The plus automatically filters your email, so it only goes to that
I
account.
know when I see on my phone or even on my computer, a little circle up there with my initial. And I know like lowercase, that's my regular email, the uppercase, but also, if I click on that little dot where the letter is, okay, it'll say, you want to go to your work mail, or it'll put that in, yes, cool. We have our own special emails that we have the ARC system. group. I was just curious about that. I was thinking that maybe somehow on hers, if I go into her account settings, maybe she's got mine on there. So I can't even pull my records from Centera when I have my doctor's appointment. She doesn't want to comment.
I would suggest when you go to the doctor, you ask them to separate those accounts.
She had to get in where she wouldn't be able to see it. So, you know, like I get my, if I go over my labs and stuff. It's put on the computer, which is great. She can go on down, I can go on down. I can't get in recently unless I say, send me this code, when it goes to her phone. She's not there, you know, X amount of minutes later, what's it? It's crazy. We have Android and stuff.
I have a question, okay, so someone's got it in their little book, they've got 5 pages of emails for about 50 companies or portals or this or that, and you want to now transfer it into the password manager. How do you enter that in so that, let's say you wanted to generate a new one and have just the one password, which is the whole point of it, right? But then every site that you have a password now for is not going to recognize that new one unless you go in and tell them that you're changing your password, right? And how does that work? Or you have to go onto that website and say, I want it, and then go into my profile and change password? But how does the password manager change that password to do that? I mean, I've got this gobbledygook thing that it's been generated.
Two directions. When you go into the website, it's going to prompt you for the password.
The one that they have.
Right, because it's not going to allow you in.
Exactly.
So you update, and it automatically talks back to the password manager, whether it's OnePass or, oh, but did you mention, is that LastPass, the situation with them?
No.
Okay. So Jimmy was focusing on OnePass. So make sure if you're going to pick one of them, pick OnePass over LastPass. Just be aware of that. It's
But I don't understand how that transfers over the
You're-
generated password to replace the password you already have on the site.
So when you go in and manually go into your password manager or your website password manager, and you make an update, as soon as you hit the website that you're interested in, it's going to prompt you. Because it's not going to let you in. It's not going to pass the way Jim described. It's going to stop you. So you then have to put in the password that you entered manually, or the one that you allowed it to create automatically.
Does it then fill that in?
Then it'll
If you're having it generated, that's the question.
pass it back.
How to replace your current one with a generated?
Sometimes when you go into change a password into an application, on a website, the browser extension for your password manager detects that you're changing that and will ask you, do you want to save this? And that's how it allocates. So you're going to initiate any differences in your passwords at the website that you're trying to get into. And then the password manager
Just updates.
will update it in its records.
But it knows to generate one?
Well, you can ask.
Replace that?
Most of them can hit it right, that mouse click, it'll bring up the subhead, and
The menu is going to tell you, just like Rob said, the menu in the password manager, you can key in the default password. I don't suggest it, or you have it generate the password for you. It links back to the password manager and locks it. Next time you go into the website, it's going to use that new password that you don't even know what it is. You can still read it, but who cares?
Yeah, okay.
Just get away from using the index card and the password books. Biggest part of my job when I go to somebody's house is trying to get them to remember their passwords. It's a nightmare. It's really, really tough.
But please, learn the password for your device. Learn the password for your, like, iCloud, or whatever, cloud service you have. And learn the password for your network. So we can help you.
And talking about networks, don't keep the network password that typically all of you, if you're either on FiOS or you're on Cox, that setup dash 12245. Don't use that. Don't use it. Make your own up. I don't care what the SSID is and the password. Make it up yourself. Don't use theirs. The reason is the minute you start switching over and you hand that gateway or panoramic Wi-Fi back to Cox, you don't reassign it to somebody else. Your password and your SSID are exactly in somebody else's hands, so don't do that. Make your own. Okay, I'm sorry, I don't mean to do that. Everybody make up your own router, password, and name.
You can store your router password in your password manager as well.
Absolutely. Absolutely.
Question. I use Safari for the longest time. And if I use Safari, they set up a password for me and it was saved in Safari. Then I switched to Google. Now I'm using Google Chrome. And I want to get into a site that I had been into in Safari previously. How does that work? How do they?
Go into your settings, go to passwords, find the URL that you're looking for, and reveal your password. Then go into Chrome, Google, and paste that in there. That's one of the disadvantages of browser-based password managers is they're specific to the environment of that browser.
Okay.
So you can export it, or you do one by one, like Jim described. You can export it, import it, critically dispose of what you exported, and you're fine. You're up and running. And it's, like I said to everyone, pick a browser, whether it's Safari, Edge, Chrome, Firefox, just pick it and stay with it. If you start bouncing around, it gets very confusing. Unless you're using a password manager. If you're using a Chrome-based or a web-based password manager, be consistent about it, because you're going to lose that continuity.
There's really no advantage or disadvantage of one to the other. It's just a matter of the environment that you're comfortable with. If you're comfortable with the Apple environment, then stick with the Apple environment. If you need something that goes across, probably Chrome is better because it's kind of independent. Edge, you want to stick with a Microsoft environment. Although they do have, they are coming around.
If you get this thing, it says, you know, it's looking for a thing, why are you doing that?
That's a capital system.
So anyway, but I'm getting in, all right, I look at my newspapers and being like you, from Jersey, there were certain comics on the comic page I still go looking at. And you get in there, it's like three that are not on the normal front cover of the section that goes with the around the newspaper out of Washington State. And I got to click on it. Once it gets going for one, it'll do for the other two. They keep asking it every time. Just those three. But then I come up on other websites. You know, I use Microsoft, MSN, something. Or I use Firefox for other stuff. And I think something said to me, go over to Firefox because Firefox is going to be the one that's going to pull down all this information.
It's whatever you're used to. It's whatever you're used to. Just be consistent, whether it's Firefox or Chrome or Edge.
The whole idea behind Are You a Human is because they want to make sure that you're not a computer that's attacking their system and causing them to have a disruption in service.
Well, I think if you're trying to go in and get into, say, against that sort of thing or whatever, and it's asking, say, hey, you can't, I gotta send you this code. So it says, okay, here's a computer like 4321 that we're used to under that person's name, but you're 789 whatever. You know, then I gotta send something over so they can get that code. Meanwhile, the person who has the original, here's some things like, here's the code, they know somebody's going into the thing. Okay, all right.
You'd have to go into your profile and make sure that where they are sending their requests is where you want to go.
It's always become recent that all this started popping up. Getting into the year, I was finalizing stuff on the ancestry, and how about now?
Maybe your wife's telling you something.
Say it again.
Maybe your wife's telling you something.
So I think we're gonna table it now. We're gonna do the raffle. I wanna thank Jim for the presentation.